Tightening a bolt requires the use of torque. Torque is the twisting force applied to the bolt during tightening. Measuring torque allows for control over the tightness of the bolt. Then the bolt can provide the right amount of clamping force. To measure torque accurately, certain areas need to be considered first. How much the bolt stretches and surfaces compress become critical during torquing. These materials must remain within their elastic limit. Elastic limit refers to the maximum a material can stretch and still return to its original shape or length. Passing the elastic limit causes the material to retain some distortion or permanently increase in length. With fasteners, the idea is to get close to the elastic limit of the bolt. This provides the most clamping force possible. Excessive tightening will damage the fastener, and less tightening will not provide ideal clamping force. Friction is the major factor in torque measurement. Torque is the energy applied to the bolt, and friction uses up most of this energy. Reducing friction puts more of the energy into the tension of the bolt. A light film of engine oil on the bolt head and threads greatly reduces friction. Note: bolt threads should only be oiled when specified to do so. Consistent tightening and a stronger joint will result from this practice. The concepts of torque become more complex when multiple fasteners clamp two surfaces together. During tightening, each bolt affects the force applied by the other bolts. Even when tightened properly, the clamping force from the bolts can vary up to 50%. Surface movement, surface quality, gasket compression, friction, and dirt affect how well the load is distributed between the bolts. Improper torquing or tightening by feel can complicate matters even more. The result is usually a poor seal, a damaged component, or both. The cylinder head can be damaged by improper torque procedures. How the head bolts are loosened and tightened affects the shape of the cylinder head. A distorted cylinder head will not seal properly. Machining the cylinder head may repair the problem, depending on how much it is deformed. Overhead camshaft towers can come out of alignment by ignoring disassembly and assembly procedures. This leads to rapid camshaft bearing wear or damage to the camshaft. Unlike warpage, this type of damage cannot be repaired. To correct this problem, the cylinder head needs to be replaced. Main bearing cap disassembly and assembly is critical to crankshaft and engine block durability. Before removal, main bearing caps must be marked to ensure they are installed in the same place. These caps distort during assembly, and control is needed to limit this action. The engine block main bearings and cylinder bores can become misaligned from improper main bearing cap disassembly and assembly. The 4.6-liter engine uses jack screws and side bolts to keep the main bearing cap distortion to a minimum. While tightening the main bearing caps, a certain amount of distortion occurs. Tightening the jack screws and side bolts bring them back to their normal position. Specific procedures must be followed during disassembly and assembly of the main bearing caps, or engine damage will result. The intake manifold on V-type engines causes concerns during assembly and disassembly. During assembly, the mounting surfaces form a wedge that push the cylinder heads outward. This action can distort the cylinder head and cylinder